This is one of my older projects. It was supposed to be a thrust testing platform where you could, remotely detonate the rocket with this mobile, I think that's 50 feet of cable. It goes in this audio jack, and then this other cable goes over here to a scale that I had hacked, and then it's also disconnected. Takeable, apartable. Anyhow, very professional handle up here. This is aluminum plate. Yeah. And there's a 24-bit ADC, I think, in there. And I think I made this back in 2020, 2021. It was during COVID. It's very dirty. I never actually posted a video about it, but I put a lot of effort into it because I wanted to, for some reason, use the ATmega Arduino chip without all the supporting stuff. So I actually soldered one in with a clock, all that stuff, and I have this SD card here, so you could load an SD card into it, and the Arduino would read this SD. I just threw it in the box. And there's the reset button. The Arduino in here would store the thrust data from this platform on the SD card. Basically, I wrote a program where you'd hit this, I think that's from a microwave door. You hit that, it shorts this guy out. The Arduino reads that and says, oh, let's run the test. And there's actually a barbecue lighter in here. This is really what killed the project, because the high voltage kind of EMF kind of messed with all of the readings from the scale. You have a really sensitive scale over here. You have a barbecue lighter. So right here, you'd have high voltage you'd run this wire over the top, right, into the core of the rocket. The original versions I used had a capacitor bank dumping huge current through Kanthal nichrome wire. That was actually much better, and I would have wanted to stick with that and not gone with the high voltage option. But basically, this Arduino would fire the rocket over here and then record the thrust. So you just have to basically set the ignition wires up with a match head or something, put it in the back of the rocket nozzle. I was also going through a phase where I was just making rockets a lot. I really wanted to make a heat-seeking guided rocket, so I also, here's one of the earlier iterations of that one. I was working on this seeker, or it was laser guided, so this would kind of like, this would be a seeker pulsed laser, so it would filter out daylight, and then you could control it. This is one of the earlier prototypes, but that was actually pretty hard. Let's see what's going on in here. How was my soldering job all those years ago? This used to be held down with rubber bands, but the rubber bands have turned to dust in 4 or 5 years. Look at all that dust. This is on the new table I built. Whoa. Yeah, I was busy. What the? Oh, wow. I bet if I replace these batteries, we would work again. So I think it's powered off 6 volts. Here's the on and off switch and all the controls. Wow, so I actually used hot glue to build up a structure in there. And then I have a DC-DC, either step down or step up. I have a 9-volt battery I'm just using for structure. That's based. Outrageously based. Oh, this is how I would program the Arduino. So, when you have the ATmega chip alone, there it is in there. I see it down there. Right, just soldered on the board. You have to connect these 4. You need ground. No. I don't know what any of this is. It's been too long. But you need 4 wires is the point to program one of the Arduino, or 3 wires for RTX. And then I have this relay bus. So the relays are controlling the high voltage. That's interesting. That's kind of dangerous. That's really interesting. I think we're going to try to plug it in, and it's just turning the dust. And that thing's really cool. This is like a mystery box. I forgot all about this. All right, so this is a 9-volt battery pack. I'm probably taking it and bucking it down to 5 volts for the Arduino and LCD and everything like that. All right, let's turn it on. See what we have. Kind of see if this thing survived all those years, or it's just gonna blow up. Nothing happened. Just connect it up. I don't think it's getting power. All right, we're bypassing the. That's a horrible noise. Stop it. Ooh, holy crap! Does that still work? What the heck? Waiting to fire. Kilograms, 0.23. What if I push on that scale? Oh my gosh. Oh, that's great. Look at that. I can push on the scale. This might actually still work. I don't believe it. And then it reads the voltage on the that's pretty cool. I must have a voltage divider in there, so it tells you your bat voltage. Okay, waiting to fire. So what's this do? Didn't write it. So that probably resets the whole system. So then if we go like this, hello. It's not doing anything. Oh, you know what this is? This is a calibration sensor. See? So you can put a known weight on the scale, and then you can twist this pot to dial it in. So it's probably a multiplier in the code. And back there is a barbecue, an electric barbecue igniter that I hacked. And a bunch of battery dust got dumped in it, but that must be powered. I'm shocked this thing still weighs, still can measure weight. Like, oh, I finally got it to count down. So it beeps. Well, that's really obnoxious. I'm going to pause it and wait for it. Oh, was that? Oh, I killed it. I wanted to see it fire those relays. All right, let's see if this actually... Sorry for all that beeping. That's really obnoxious. You know, I was going to take this apart because it's been sitting here for a long time, but kind of makes me want to build rocket engines again and test them. Because this still weighs the weight properly, and it has an SD card down there that I dropped. But see the SD card reader right there? And, you know, I did a lot of programming and mutzing around for like a month. So, interesting. The barbecue lighter isn't working, but that's fine. We can flip relays. I just have to figure out which relays going on. See, this is the old setup I had. It's just a scale traced out to an Arduino. So the thing I was just showing you was like the next iteration. I was making these little brass. Oh, it's still on. Yeah, you had stuff like this happening. Literally a bomb. That was terrifying. So here's the schematic. Probably. You have a potentiometer for control. We have the firing sequence. We have the SD card reader, the LED, the balancing clock, some control relays, and the strain gauge feeding data. So, interesting. Meh. I gotta go to sleep, but if you made it this far, congratulations. You get to see this awesome constant current circuit I might have stumbled upon. Basically, there's a shunt here, and it's only two transistors, an NMOS, very easy to use, and 2N3904, very easy to use, right? Shunt generates voltage when current flows, which turns on this transistor, which grounds out the base of this MOSFET down to here, which reduces the current. So this falls into a steady state canyon of current flow of about 500 milliamps. And this resistor is actually what controls how that works. So you could go to 10K, and we have actually attenuated down to 400 milliamps. There's another version of the circuit that has an op-amp here, but that's more components, you know. Yeah, it might be more stable and not sensitive to temperature change, but check this out. So let's say we're tuned in at 400 milliamps. Here's the load. Let's do 1 ohm. Boom. Still 400 milliamps. You can see the voltage is going to always add up to the source voltage plus the voltage over this shunt between these two. So the MOSFET is going to take the brunt of the load, only almost 10 watts here, while the load is going to be reflecting most of the power. But we can go to like 50 ohms. Boom, still 400 milliamps. Pretty nice. But now we have most of the load over this 50 ohm. Now once this resistor gets high enough, eventually the current will drop because it's just going to attenuate the... I think 100 will cut it down. Yeah. See, now we're putting all the voltage we can across it, but it's still not enough to equal that 400 milliamps we had. So very interesting. You can hook that NMOS on a big old heat sink and sink probably a constant current of an amp or two. I just used a circuit like this at work, so it was very cool. All right, have a great day.